Hello, I am Mr. Lee, Chemsir. This video clip is to discuss with you the answers in the pre-mock examination, the section B. So let's start. Question number 1. First of all, you need to check the atomic number of titanium from the periodic table. And then you find the 22. And then you do the subtraction. You get the answer to be 10. In part B, you are given the relative atomic mass of titanium, and there are 5 isotopes. It seems that there are 2 unknown relative abundances. Actually, they are related because the sum is 100. So, in the part 2, y is actually equal to 12.8 minus x. Therefore, you got only 1 unknown. So you can establish this equation and then you can solve the x and y. In part 1, you are asked the meaning of the term isotopes. Make sure you know you must write the word atoms in your answer, and then you have to mention further atoms with the same number of protons but different numbers of neutrons. So when all these are included, then you get the 1 mark. Part C, actually you are just required to follow the instructions given by this question. So Ti reacting with HF to give this complex anion, and hydrogen gas, of course H2, and hydrogen ions, of course H+. And you are further provided the mole ratio, hydrogen to hydrogen ions being 1 to 2. So after some consideration, you should be able to write this equation successfully. Just to remind you that actually, as the question already implies you to include the mass number 47, so you better write the mass number 47 here in your equation. Part 2. Explain whether the reaction is a redox reaction. Whether, therefore you have to say yes first, this is a redox reaction, and then you mention the change in oxidation number of the element involved. For titanium, it is from 0 to positive 3. Remember that you have to mention positive. When I marked the paper, I found some of you wrongly put down H. H is of course correct, but some of you wrongly put down H+. So make sure you don't make such a mistake again. And also I found some of you not careful enough. 1 is of course wrong. Should be from positive 1 to 0 for the change of the oxidation number of H. In part 3, if titanium 48 is to replace titanium 47 to react with the HF, make sure you know that these 2 are isotopes of titanium. Isotopes should have the same chemical properties. I repeat, same chemical properties. You must write same chemical properties. I found some of you wrongly put down similar chemical properties. This is incorrect. Okay, same chemical properties for isotopes. The observation, of course, pops out. As you were told earlier, hydrogen gas will be produced in this reaction. Part D. First of all, make sure you must be careful enough to observe that the titanium 4 chloride here is existing in the form of molecules, because the question gives you the hints already, molecule. Therefore, it is covalent in nature, and your concept should be good enough. Please don't think that titanium 4 chloride is ionic, even though titanium is a metal. Actually, you learn such an idea in the DSE syllabus. Do you know which topic? Did you learn BeCl2 before? In the topic Microscopic World 2, shape of molecules, something like that, okay? So BeCl2, of course, Be is also a metal. In that topic, you learned that BeCl2 is a linear molecule. Of course, it is non-octet structure. And this is the structural formula for BeCl2. And for BeCl2, you will not think of this because you are told that it is covalent. So make sure you know that actually a metal compound may be covalent. So for this TiCl4, it is actually covalent in nature. Anyway, you have to be careful about the hint provided by the question. Shape, of course, tetrahedral. When I marked the paper, I found some of you put down tetrahedron. I think this is not acceptable, okay? Make sure you should write tetrahedral as the shape. Why electrolysis of titanium 4 chloride cannot extract the metal? You have to say not feasible, cannot. But why? As you are told that it is covalent. It exists in the form of simple molecular structures. Therefore, it actually cannot conduct electricity. But why? The reason behind is there are no mobile ions and no delocalized electrons. So make sure you have the complete idea. No mobile ions and no delocalized electrons for this compound to conduct electricity. Therefore, you cannot extract the metal by electrolysis. Question number 2. This reaction talks about the reaction between metal and steam. Actually, in part A, you are asked the question. In fact, the wet cotton wool is to provide the steam so that the hot sink can react with the steam, giving the hydrogen gas by this equation. Part D. Please make sure that you have to take out this delivery tube from the water level as the first step. Many of you answer this question poorly. This is the step 1. You must do this. Of course, in your answer, you must also mention the step 2. That is, remove the heating source. And of course, you connect them together using words like before. Then your answer becomes very complete. Of course, once you can do this, you get the first mark. And then why you have to do so? It is because if you don't do this, sucking back will occur or the boiling tube will be cracked. So this is the second mark. Question number 3. This question talks about prevention of rusting of iron by magnesium. Magnesium can protect underground iron pipelines from rusting by connecting it to magnesium. Okay, why magnesium can conduct electricity? in terms of structure, therefore you have to mention the giant metallic structure, and then the reason behind magnesium can conduct electricity is, of course, the presence of the sea of delocalized electrons. I found some of you could not mention sea of, just mention delocalized electrons. That is not good. Not good. Part B. Essential conditions for rusting of iron, of course, including water and air. You have to mention both. Part C. Direction of electron flow in the process. Of course, the underground pipeline, okay, may be like this. This is made of iron, and then it is connected to a bag of magnesium, and the direction of electron flow is, of course, from magnesium to iron, because magnesium is more reactive than iron. This is the reason behind. And then in part 2, you are asked whether the iron pipeline is the anode or the cathode. So make sure your concept is good enough. The electrode at which there is a loss of electrons is the anode. And Fe is, of course, the cathode. Therefore, you have to answer cathode. And the reason behind is, of course, you have to mention reduction takes place at iron. Right here, if you mention magnesium being more reactive than iron, it is not acceptable, because you are asked whether iron is cathode or anode. So when we use the terms cathode or anode, we refer to whether oxidation or reduction takes place. So make sure your concept is good enough. Part 3. Principle of this protective method. Of course, based on the difference in the reactivity or difference in the tendency to lose electrons. Question number 4. This tricarboxylic acid is, of course, a weak acid, as it is an organic acid with carboxylic acid functional groups, just like ethanoic acid, okay? So, the meaning of a tri-basic acid, first of all, it is an acid that gives 3 hydrogen ions when each molecule ionizes in water. Part B. When I marked your paper, I found quite a number of you could not mention the correct acid-base indicator, and of course, the correct color change of the indicator at the end point. Make sure you know how to determine the answers. As I mentioned, the acid involved here is a weak acid. So, weak acid. In the titration, the titration also involves sodium hydroxide, which is a strong alkali. So, weak acid against a strong alkali, we have to use phenolphthalein. Then, how to determine the color change? Check from here, okay? 25.0 cm cube, of course, we have to withdraw this volume using a pipette. So the acid was withdrawn from a pipette. Then, what will happen later on? Of course, the acid will be dropped to the conical flask. So in the conical flask, before the titration, there is the exit, and then we add the phenolphthalein indicator. Therefore, before the titration, the color of this mixture should be colorless. Later on, of course, we use the burette to contain the sodium hydroxide solution. How can we know or how can we confirm? It is because the volume of the sodium hydroxide solution used is 26.20 cm cube. This is of course measured by a burette. Of course, you know that after this amount is added to the mixture in the conical flask, finally, there will be a color change from colorless to pink. So this is the way to determine the color change at the end point. Part 2. In the calculation, first of all, I think it is so trivial to find the number of moles of sodium hydroxide solution used because just simple calculation is involved. When I mark your paper, I found quite a number of you could not do the subsequent calculation. Make sure you should recall the fact that the acid involved is a tri-basic acid. Suppose its formula is simplified to be H3X, okay, tri-basic acid. Then, if it is to react with sodium hydroxide solution for a complete neutralization reaction, the salts produced should be Na3X and of course H2O as the other product. To balance the equation, of course 3 here and 3 here. So the mole ratio acid to alkali is 1:3 based on this balanced chemical equation. And therefore, from the number of moles of sodium hydroxide, then you determine the number of moles of the acid based on this 3:1 ratio, mole ratio. You have to divide the number of moles of sodium hydroxide by 3. When I marked the paper, I found quite a number of students wrongly do the calculation using times 3. Of course, this is incorrect. Divide the number of moles of sodium hydroxide by 3 is the correct way. Finally, towards the end, you have to multiply this factor to the number of moles of acid you calculated, because during the experiment, there is such a step: you extract or withdraw just 25 from 250 cm cube of the sample. So you have to include this factor. And finally, as the original volume is 250.0 cm cube, you have to do this number of moles divided by volume to get the molarity of the acid. Right here, make sure you write good answers by showing the 3 significant figures, because you will find that the data provided by the question are mainly correct to 3 significant figures. For example, this one. For example, this one. Okay, so how to determine? Just refer to the data from the question. So 0.122 m is a very good way to present your answer. If you just present it to be 0.12 m, this is not good, not accurate enough. Question number 5. Systematic name of the compound X. Make sure you can circle the longest continuous carbon chain, this one, okay? Next, you have to number the carbon atoms correctly. Of course, starting from this side. This is number 1, this is number 2, because the carbon-carbon double bond will appear earlier if you start numbering the chain like this. So this is 6 carbon atom, hex 2 in. This is showing the position of the double bond, and then of course this is the 2 chiral group, this is the 4-methyl group. Bear in mind that these 2 prefixes should be arranged in alphabetical order. So C goes first, and it is followed by M. Therefore, 2 chiral 4-methyl hex 2 in as the systematic name. Part B. Presence of carbon-carbon double bond. Of course, normally we use either bromine or acidified potassium permanganate solution. And the color change is of course from brown to colorless. It is always better if you can also include the rate of reaction by using the word rapidly. If you use permanganate, then the color change will be from purple to colorless rapidly. Part C. Catalyst, either platinum or nickel. Name the type of reaction, addition reaction or hydrogenation. The last part, draw the repeating unit. I found quite a number of you made mistake. First of all, make sure you can extract the information from the structure of the monomer. And what you are doing is to locate the CC double bond, and then the other 4 groups. This is the first one, number 1, number 2, number 3, and number 4. So what I just put down is number 1, number 2, number 3, number 4. So these 4 groups should be drawn like this. 1, 2, 3, and 4 in such a pattern. 1, 2, 3, 4. And of course, later on, you have to extend these 2 parts because this is to be a bond bonded to another carbon atom. On the other side, another covalent bond bonded to the other carbon atom, and so on. And then finally, you have to draw the square bracket. Normally we do this, okay? So this is the way to draw the repeating unit. When I marked the paper, I found some of you could not draw the 4 groups 1, 2, 3, and 4 like this. Then you make mistakes. Another kind of mistake is that some of you wrongly put the CC double bond in the structure of the repeating unit. Of course, CC double bond is incorrect. Furthermore, I found some of you wrongly drew this structure, this part, by showing the C4H9. This is not acceptable because C4H9 doesn't mean this structure, okay? So C4H9 is somehow condensed, showing the number of atoms only, not showing the structure. So this is incorrect. So be careful later on when you are asked this kind of question. Question number 6. Lithium aluminum hydride is a strong reducing agent, and it is very useful in organic reactions. 2 hazard warning labels based on the reaction provided. So the hint is already given. Lithium hydroxide is corrosive. And then hydrogen is flammable. So 2 marks for these two hazard warning labels together with the explanation. When I mark the paper, I found some of you wrongly consider that lithium aluminum hydride is oxidizing. Of course, it is totally incorrect. Actually, you should be very familiar with its role to be a reducing agent. How can it be oxidizing? So, totally incorrect. Part B. You are given the standard enthalpy change of formation. This is the meaning, and I'm not going to discuss in details, just to highlight that some of you did not show this part, so that is not good. In the calculation, make sure you know that you are provided with the standard enthalpy change of formation, the data, and therefore in your calculation you should use the method standard enthalpy change of formation of products summation minus the summation of delta HF of the reactants. While you are doing this, be careful about the balanced chemical equation showing the coefficients 4H2O on the left and 4H2 on the right. And therefore, we found the 4 here and 4 here. This is 0 because the standard enthalpy change of hydrogen is 0. So make sure you have to include this 4 so that you can get the correct answers. Question number 7. Iron 2 sulfate 7 water. First of all, iron 2 sulfate is a soluble salt. And then 7 water is of course showing that it is a hydrated crystal. To prepare a soluble salt, we may use excess iron. The term excess is so important here. Should be added to dilute hydrochloric acid. And then the excess iron can be filtered off. Then heat the filtrate so that it becomes saturated or concentrated. And refer to the question, you are expected to prepare large crystals. Therefore, you have to cool the hot solution slowly. By cooling it slowly, you get large crystals. Once you got the crystals, of course, you obtain the crystals by filtration. And then, towards the end, okay, finally, you dry your hydrated crystals using filter paper. Make sure you know that oven is not good here, not recommended, because the high temperature in the oven may allow the decomposition of the iron 2 sulfate 7 water to occur. For example, the water of crystallization may be removed, or even, let me tell you, the iron 2 sulfate is actually not quite stable at high temperature. Of course, this is beyond the scope of DSE chemistry syllabus. So let's put an end here, and there will be another video clip talking about the remaining questions of this section B.